All right, so we're going to pick up where we left off in the last class. As you recall, we had been going through a number of probability distributions or random number generators that we will be using to construct our models and embrace uncertainty within our models. And we had just started talking about this example with this beautiful canvasback duck. And specifically, we were imagining a scenario where we were part of a research team that had been studying a population of canvasback ducks over a 20-year period. And specifically, we've estimated the average number of eggs successfully hatched per female for each of 20 consecutive years for this canvasback population. And we can enter the numbers we collected into R. So we could copy this, these R statements, and move these into R. I could paste this back in, and if I run this line with Control Enter and Control Enter here, I can see a histogram of all the data that we've collected over the past 20 years. All right, save that and go back to the lecture. And this is what the histogram looks like again, and we can ask a question now: what type of uncertainty does this set of values most likely represent? That is, we've talked about different types of uncertainty in population models. One type of uncertainty is just lack of knowledge. One type of uncertainty is demographic stochasticity, for example. That's luckiness or unluckiness at the individual level. And then we have environmental stochasticity, which is luckiness or unluckiness at the level of the population. So the question is, what type of uncertainty does this set of values most likely represent, and what random number generator might you use to represent this uncertainty? Please take a minute to go to Top Hat and answer that question. All right. After you've answered that question, let's resume the lecture. What we're going to do here is try to fit a distribution to these data. We could choose to use a normal distribution, which would be acceptable. But because the total per capita number of eggs successfully hatched cannot go below 0, it's more appropriate potentially to use a log normal distribution. So that's what we're going to do, and we're going to do this in R. We could use statistics, but this isn't really a statistics class. So we're going to use trial and error to fit this distribution. So I gave you some code to get started, and I encourage you to move on to RStudio and load this code into RStudio. So we recall that the log normal distribution has two parameters. The first parameter is called mean log, and it helps to define the mean, and the other parameter is SD log, which helps to determine the variability of the distribution. So let's move this code into RStudio, and we can play around with this a little bit. All right. So again, here's our histogram, and I've made it a little bit different so we have more space on the x-axis and more possibilities, because we're going to be playing around with different distributions, and it'll be nice to be able to visualize those different distributions. Now we're going to use a function called the curve function, which just is a shorthand, a convenience function that R provides for drawing a curve on top of an existing plot. And we're going to draw a curve that represents the log normal distribution, and we're going to use a function called dlnorm for the log normal probability density function, and this x just represents the range across which we want to display the log normal distribution. And Mean log represents an initial guess at the mean log parameter, which defines the central tendency of this distribution. And the SD log, and I just threw in a value of 0.39 to get us started. But again, it's just a guess. We're going to do trial and error here and try to find the best values that fit this distribution. I'm going to make the line colored green. It's going to be a thicker line, so line type or LTY equals 2 will make it a, that's going to make it a dotted line. When we make it a thicker line, LWD equals 2 makes it a thicker line, line width. And add equals true will draw it to the previous plot, so it'll add it to this histogram figure. So let's run that line, Control Enter, and now I see that the log normal distribution that I just specified, this initial guess, is not the greatest distribution to fit this. It's not the greatest values to fit this distribution. So what I'm going to ask you to do is to play around with the mean log parameter, just the mean log parameter for now, and identify which mean log parameter value best fits the distribution of hatchlings produced per female from this Canvas-back duck population. So take a few minutes to do that, and I will resume in the next video.